Akshara Foundation's video on fractions. If students gain a good understanding of the basic concept of fractions by Standard 5, then they will enjoy the subject in higher classes. In the previous video, we spoke about addition and subtraction of basic fractions. Using the teaching aids found in Akshara's Maths kit, you can now introduce students to the concept of equivalent fractions. Here's a little trick before you start. Dip these teaching aids in a little water and see how easily they stick on the board. Take a fraction strip marked 1 and using a little water, stick it on the wall or blackboard. Next, take 2 strips each marked 1/2 and place them next to the strip marked 1. Tell students how 1 or the whole can be divided into 2 equal parts. That is 2/2, which equals 1. Similarly, take 4 strips each marked 1/4. Tell students how 1 or the whole can be divided into 4 equal parts. That is 4/4, which equals 1. From the above example, we can now see that 1 equals 2/2 and also equals 4/4. Thus, 2/2 and 4/4 are equivalent fractions as they have the same value, that is 1. Can we say 4/8 equals 2/4 equals 1/2? Yes, we can. Use fraction strips to indicate that 4/8 equals 2/4 equals 1/2. You can also use another example to show equivalent fractions by dividing a circle into 2/3, 4/6 and 8/12. Let us relate equivalent fractions to a real-life example using chocolates. Geeta, Raju and Amina each have a bar of chocolate. Geeta breaks her chocolate into 2 parts and eats 1 part. Raju breaks his chocolate into 4 parts and eats 2 parts. Amina breaks her chocolate into 8 parts and eats 4 parts. Ask students to observe who among the 3 friends ate more of the chocolates. Students will see that each friend ate the same amount of chocolate. So 1/2, 2/4 and 4/8 have the same value. Hence, they are called equivalent fractions. Equivalent fractions can also be explained by establishing a fraction series. Here is a rectangle divided into 3 equal parts. Shade 1 part and ask students how many parts are shaded. Students should be able to tell you that 1/3 of the rectangle is shaded. Now, draw another rectangle of the same size and divide it into 6 equal parts. Shade 2 parts. Students would be able to say that 2/6 of the rectangle is shaded. Ask students to observe that both the rectangles are of the same size and the area that is shaded in both the rectangles is the same. Hence 1/3 equals 2/6. Now ask students to notice that 1/3 multiplied by 2/2 will give you 2/6. Now introduce a third rectangle of the same size and divide it into 9 equal parts. Shade 3 parts and explain to students that 3/9 of the rectangle is shaded. Again, this rectangle is of the same size and the shaded area is also the same. 1/3 is equal to 2/6, which is also equal to 3/9. Show them how 1/3 multiplied by 3/3 is equal to 3/9. Repeat the same process by introducing a 4th rectangle of the same size and shading 4 out of the 12 equal parts. Show how 1/3 multiplied by 4/4 is equal to 4/12. Ask students to observe the fraction series where all fractions are of equal value or in other words, relationship of part to the whole is the same. Explain how a fraction series can be derived by multiplying the fraction with the same number in the numerator and denominator as we have just shown above. Because you are multiplying by 1, they are equal in value. If students want to check whether two given fractions are equivalent, here is the cross multiplication method to do so. For example, we can take 3 upon 4 and 9 upon 12. Cross multiply 3 by 12 and 4 by 9. We see that the numerator and denominator have the same value, that is 36. Or in other words, as we have found earlier, it is 1. Hence, 3 upon 4 and 9 upon 12 are equivalent fractions. Is 2 upon 7 equivalent to 4 upon 9? Let us check. Using the cross multiplication method, we get 2 into 9 which equals 18 and 7 into 4 which equals 28. That is 18 upon 28. Ask students to observe that the numerator and denominator are not the same. Hence, 2 upon 7 is not equivalent to 4 upon 9. You can also explain to students that they can find equivalent fractions through simplification of a given fraction. Use an example of 4 upon 8. We see that 4 and 8 can both be divided by 2. That is, 4 divided by 2 equals 2 and 8 divided by 2 equals 4. This gives us 2 upon 4. If we further divide 2 upon 4 by 2 upon 2 again, we get 1 upon 2. From this simplification process, we understand that 4 upon 8, 2 upon 4 and 1 upon 2 are all equivalent fractions. For a quick review, you can ask students to find equivalent fractions by using different methods. Using multiplication, write the next two equivalent fractions in the series. Using cross multiplication, check if the two fractions are equivalent. Simplify the following fractions. You can now make learning equivalent fractions fun for your students.
Maths allide yentha khushi yentha maja baba ni nodu ba